Welcome to another video tutorial for Learning Music Theory with Logic Max and Finale, published by Routledge and written by Jeffrey Kidda. In this video tutorial, we'll discuss the Diatonic Progression Generator, an app created in Max that helps us understand harmonic progressions. We'll start with two 4-chord progressions played one after the other. We'll hear these same progressions then played where all of the parts are moving in parallel motion, which creates instances of perfect intervals moving in parallel motion. This is one of the things we're trying to avoid in creating progressions in a traditional concept. We'll then hear how we can resolve the tendency tones of the dominant 7th chord, and we'll also then hear how we can invert the dominant 7th chord and how those resolutions work when we invert the dominant 7th chord. We'll hear how we can create common tones between chords, and then we'll hear a series of bass patterns, starting off with a descending fifths bass pattern, then hearing the Pachelbel canon in D, which includes fourths and seconds in the bass, and then a bass pattern with thirds and fourths, and finally a bass pattern with descending thirds. We'll finish up by hearing a short excerpt from Joni Mitchell's song Both Sides Now, which incorporates tonic chord and subdominant chords in second inversion alternating, creating a pedal bass on the tonic note. How does the Diatonic Progression Generator work? Well, it plays 8 chords in succession, and for each of the 8 chords, we can change the parameters. In the first table, we can change the octave position. In the second table, we can change the Roman numeral, that is to say which chord we're going to hear. Then we can change the position of the chord in the third table, selecting between root, first, or second inversion, and also the third inversion for the dominant 7th chord. We can adjust the voicing of any of the chords, and in this case the voicing leaves the bass note alone but changes the octave position of the upper 3 notes. And then finally we can change the rhythmic values of the chords to hear the progressions played with different rhythms. You can choose to change the key to any key, and you can also choose between major and minor tonalities. To hear all 8 chords in sequence, click on the sequence toggle, then click on the Start Step button. To hear individual chords in succession, click on the Start Step button, and to repeat chords, click on the Current Step button. The Diatonic Progression Generator is available from www.jeffreykidda.com. In the first example, we have 2 4-chord progressions. They both include the 3 harmonic functions: the tonic function, the dominant preparation function, and the dominant function. In this case, the dominant preparation function is heard in the supertonic or 2-chord and the subdominant chord, the 4-chord, and the dominant function is heard in the 5-chord or the 5/7 chord. We'll take these 2 4-chord progressions and then hear what they sound like when we have the chords all in the same voicing. And this creates parallel motion between the voices. Now, parallel thirds or sixths are considered to be acceptable in voice leading practice, but parallel perfect unisons, fifths, and octaves should be avoided because they diminish the independent identity of the voices. And we'll hear what that sounds like in this example. So in this example, the bass and the alto voice have parallel octaves, and the bass and the tenor have parallel fifths. In the next example, we'll hear how tendency tones of the dominant 7th chord are resolved. The 2 tendency tones are the 7th and the 3rd, and the 3rd is also called the leading tone. The 7th always resolves down to the 3rd scale degree of the tonic. The leading tone must resolve upwards if it's in the soprano or bass voice. That's to say, if it's in one of the outer voices. We can invert the dominant seventh chord. If the dominant seventh chord is in the first inversion, the leading tone is in the bass and therefore must resolve upwards. If the dominant seventh chord is in the third inversion, the seventh is in the bass and therefore must resolve downward to the third. The resolution of the dominant seventh chord in third inversion requires that a first inversion tonic chord come as a resolution so that that seventh can move down to the third. In many progressions, we will hear common tones between chords. Common tones are simply notes which are held in the same octave position from one chord to the next. This creates a smooth sounding progression. In this example, in F major, the A in the melody is held between the tonic, median, and submedian chords in the first 5 chords. It creates a very static melody, and it's just staying on the same pitch, of course. So that's not necessarily something you want, but it does create a very smooth sound. Next, we'll have a series of bass line progressions that have patterns. So in the first case, we're going to hear the pattern of descending fifths in the bass. The bass line of a progression moves by descending fifths, or the equivalent, the enharmonic equivalent of the ascending fourths. The fourths and fifths are all perfect except for the move between the subdominant to the leading tone chord, which in this case is an augmented fourth. Pachelbel's canon in D has a root bass pattern of descending fourths and ascending seconds. In this case, the voicing parameters are chosen to recreate the melodic shape that we can hear in the original piece. Next, we have a bass pattern which includes descending thirds and ascending fourths. And finally, we have a bass pattern which includes descending thirds. The last example is a short excerpt from Both Sides Now by Joni Mitchell. We're hearing the tonic chord in root position and the subdominant chord in second inversion, and this creates common tones in the bass, and we can call this a pedal bass. The melodic shape of the passage has those wide jumps that are heard in much of Joni Mitchell's vocal creations. Thanks for watching.